The topic of today's video lecture is heterogeneous versus homogeneous catalysis. So what we are going to do, we are going to compare both of these catalysis. So what is homogeneous catalysis? The homogeneous catalysis is actually the type of catalysis in which the reactants and the catalyst both are in same phase. Let's just say that our reactants are in gas phase, then the catalyst should also be in the gas phase. So this is an example of homogeneous catalysis. So let's just talk about the heterogeneous catalysis. In heterogeneous catalysis, what do we have? The reactants and the catalyst have different phases. Let's just say that the reactants are in gas phase, then the catalyst should be in the liquid phase or it should be in the solid phase. So the type of catalysis in which there is a different phase for the reactant and the catalyst is known as the heterogeneous catalysis. So now moving on towards their comparison. First of all, when we talk about the activity, what is the activity? Activity is actually the efficiency of the catalyst. Okay, activity is actually the efficiency of the catalyst. So when talking about heterogeneous and homogeneous catalysis, the activity is comparable. Okay, there is no difference between the activity of heterogeneous or homogeneous catalysis. Both have comparable activities to each other. Talking about the second point, reproducibility. Reproducibility. What is reproducibility? Well, reproducibility is actually the extent to which consistent results are obtained when an experiment is repeated. So, in case of the heterogeneous catalysis, we will have difficulty in obtaining the consistent results when an experiment is repeated, whereas in homogeneous catalysis, we will get reproducible results. And the third point is selectivity. What is meant by selectivity? Selectivity is actually the property of a catalyst to only form one type of product is known as selectivity. So heterogeneous sites, since in case of the heterogeneous catalysis we have heterogeneous sites, means that different sites will have different affinity for the reactants. So that's why in the product we will have lesser selectivity as compared to the homogeneous catalysis, whereas in homogeneous catalysis we have a homogeneous catalyst and it is easy to optimize and various type of selectivities can be obtained by homogeneous catalysis. Talking about the fourth point, reaction conditions. Well, for heterogeneous catalysis, we need higher temperature and pressure, and whereas the heterogeneous catalyst have better thermal stability. Means the in case of the heterogeneous catalysis, you can raise the temperature to a very high value and still the catalyst would be stable. While in case of the homogeneous catalysis, you must maintain a lower temperature that is less than 250 degrees C and a higher pressure. And finally, the homogeneous catalysts have lower thermal stability. So a homogeneous catalyst is not able to withstand a higher temperature. Well, talking about catalyst cost and recovery, the heterogeneous catalyst is used in high volume and it has low cost, and the recovery is easy, means that you can recover the catalyst at the end of reaction very easily. Whereas in case of the homogeneous catalysis, you have to use the catalyst in low volume because it is of high value, means it is highly costly, and recovery of the homogeneous catalyst is also difficult. So that's why this is one of the major drawback of homogeneous catalysis. Talking about the active sites, nature and accessibility, the in case of the heterogeneous catalysis, the active sites are not well defined. As I have just told you before, that the heterogeneous catalysts have heterogeneous surfaces, and each active site on the heterogeneous surface does not have same affinity for the reactant molecules. So that's why we say that in case of the heterogeneous catalysis, the active sites are not well defined, but they are again tunable. Well, talking about the homogeneous catalysis, the molecular active sites, there are molecular active sites and they are very well defined and homogeneous and uniform active sites. And again, these are also tunable and accessible. One more point, and also have limited accessibility, because as you know, in case of the heterogeneous catalysis, for example, let's just say that gas reactants, that in case of a reaction in which the reactants are in gas phase and the catalyst is in the phase of solid, and the catalyst is in the solid phase, the gases cannot reach to all the active sites of the reactant. So that's why there will be limited accessibility. Whereas when we talk about the homogeneous catalyst, since the gases and the catalyst are in the same phase, so the all of the sites of the catalyst are accessible. And talking about diffusion limitation, diffusion limitations occur when the reactant molecules are trying to diffuse into the catalyst molecule. So, well, talking about the heterogeneous catalyst, in heterogeneous catalysis, there is diffusion limitation, and it can be eliminated by applying the proper reaction condition. In case of the heterogeneous catalysis, we have a heterogeneous catalyst. For example, let's just say that we have a solid catalyst, and the gases will have difficulty to diffuse into the solid. And again, when we talk about the homogeneous catalyst, then we can say that the diffusion limitation can be easily overcome just by stirring. For example, let's just say that the reactant are in the liquid state and the catalyst is also in the liquid state. So the reaction can be performed by just stirring at higher rate. So the diffusion limitation can be overcome easily by optimization of stirring. Well, talking about the catalyst life, in heterogeneous catalysis, the catalyst have a relatively longer life and regeneration is also feasible. Whereas in case of the homogeneous catalysis, the catalyst life is relatively shorter and regeneration may or may not be feasible. Because as you know, when we talk about the homogeneous catalysis in which the product is in the liquid state and the catalyst is also in the liquid state, then for the regeneration of the catalyst, for the separation of the catalyst, you will have to perform some processes like that of distillation, because distillation will separate the catalyst and the products according to their boiling points. And talking about the reaction kinetics, well, in case of the heterogeneous catalysis, you know that there is a difference of phase, so that's why we have complex kinetics and mechanism, and it is very difficult to establish and understand. But days are not far off when all of these complexities will be removed. Well, talking about the homogeneous catalysis, the reaction kinetics, mechanism, and catalytic activity could be established and understood with relative ease, because as you know, again, in homogeneous catalysis, the reaction kinetics, mechanism, and catalytic activity can be easily understood. Susceptibility to poison. Heterogeneous catalysis are again highly susceptible to poison, whereas the homogeneous catalysts are relatively less susceptible to the poison. And moreover, they are usually sensitive to water and oxygen. Well, now talking about the last point, industrial application. Heterogeneous catalysts are used in bulk or commodity products manufacture, and this cover up about 85% of the industrial application, whereas the remaining 15% of the industrial application like pharma, fine and specialty chemicals manufacture, this is performed by using the homogeneous catalyst. So that was the basic difference between the heterogeneous and homogeneous catalysis. So if you have any question, you can ask in the comments. Thank you and Allah Hafiz.